இன்ஆர்கானிக் கெமிஸ்ட்ரியை பொறுத்த வரைக்கும் முதல்ல நீங்க தெரிஞ்சுக்க வேண்டியது டைட்ரேஷன். இந்த டைட்ரேஷன்ல ஃபர்ஸ்ட் மோர்ஸ் சால்ட், இதை நீங்க எக்ஸசைஸா பண்ணியிருப்பீங்க. யூ மைட் ஹவ் டன் த எக்ஸ்பெரிமெண்ட். மோர்ஸ் சால்ட். Morse salt is FeSO4 ferrous sulfate and ammonium sulfate 6H2O. This is Morse salt. This is called a double salt. Double salt means two simple salts together. This is called a double salt. If the salt gets ionized, it will be ionized into Fe2 plus, SO4 2 minus, and then 2 ammonium radical, and then again SO4 2 minus, and then this 6 water of crystallization will be there. So now, the last year one question was asked. How will you prepare a solution of ferrous ammonium sulfate? This is called a ferrous ammonium sulfate or ferrous sulfate. Ferrous sulfate or ferrous ammonium sulfate. Ferrous sulfate is a simple salt, FeSO4. Ferrous ammonium sulfate is a double salt. These salts are prepared not in pure water, but with a little amount of dilute sulfuric acid. This question was asked in the NEET last year. How will you prepare a solution of ferrous ammonium sulfate? Ferrous ammonium sulfate solution is prepared with a dilute sulfuric acid. Now, the equivalent weight of a ferrous ammonium sulfate is 392.1, and the equivalent weight of ferrous sulfate is 278. So these equivalence weights are very important. Now, if you want to calculate the equivalent weight, look at the redox reaction. In ionic form, MnO4 minus, MnO4 minus is actually coming from KMnO4, leaving the K plus ion, KMnO4 plus H plus Fe2 plus Fe2 plus giving Fe3 plus Mn2 plus H2O. This is the redox reaction taking place during the titration between ferrous ion and the KMnO4. So look at the charge of manganese here. It is for oxygen 8 minus, so X minus 8 is equal to minus 1. Therefore, X is equal to plus 7. So here it is plus 7 oxidation state. Iron is plus 2 oxidation state here. This side it is plus 3 oxidation state. And the manganese is plus 2 oxidation state. Therefore, the magnesium from plus 7 to plus 2 is getting reduced by gaining 5 electron. whereas ferrous ion is oxidized to ferric by the loss of one electron. Every detail is very important. So as 5 electrons are involved, the equivalent weight of KMnO4 is its molecular weight divided by the number of electron transfer 5. So its molecular weight is 158. So divided by 5, you are getting 31.6. So 31.6 is the equivalent weight of KMnO4. Actually, equivalent weight does not have any unit. It is 31.6 means if you take 31.6 gram of KMnO4, it is 1 gram equivalent of KMnO4. So this idea you should have. What is 1 gram atom or 1 gram molecule or 1 gram equivalent? This will be involved in so many calculations. 1 gram equivalent means taking the equivalent weight gram of the substance. Equivalent weight gram of the substance is 1 gram equivalent. 1 gram atom means if you take hydrogen, the atomic weight of hydrogen is 1.008. So if you take 1.008 gram of hydrogen, it is 1 gram atom. 1 gram molecule means, suppose if you take a carbon dioxide, carbon atomic weight 12 and oxygen 16 into 16, 16 plus 16, 32, therefore 44. The molecular weight of carbon dioxide is 44. If you take 44 gram of carbon dioxide, it is 1 gram molecule. So this idea you should have. 1 gram equivalent means taking equivalent weight of the substance, So you might have understood this. Now, I write another equation where oxalic acid is oxidized. What is oxalic acid? Oxalic acid is COOH. COOH. This is oxalic acid. Normally, this oxalic acid is written as C2O4H2. Actually, these two H2, they can leave the acid as H plus ions. So this can be written as C2O4 2 minus. So the C2O4 2 minus is oxidized by KMnO4. You should understand this particular point. Again, it is MnO4 minus plus H plus C2O4 2 minus giving Mn2 plus H2O plus CO2. Actually, I have not balanced this equation. Manganese, it is in +7 oxidation state. Here it is +2 oxidation state. So it has gained 5 electron. Here, in the oxalate ion, This is 2x minus 8 is equal to minus 2. So x is equal to 3. Here it is minus 4. So x is plus 4 charge here. Here it is 3. So there is 1 electron. But for 2 carbons, 2 electron transfer. That is why in this reaction, the equivalent weight of KMnO4 is its molecular weight. Molecular weight is 158 by 5 electron transfer. It is 31.6. For oxalic acid, the equivalent weight is its molecular weight by the number of electron transfer 2. Therefore, it is 126 by 2. It is 63. So this is how the equivalent weight and the molecular weight are calculated. But the very important thing is whether it is a KMnO4 or K2Cr2O7, they act as oxidizing agent only in the presence of sulfuric acid. So sulfuric acid is a very important component to be added in the titration so that the KMnO4 or potassium dichromate will act as oxidizing agents. Now I want to write the balanced equation for all the reactions. See, it is MnO4 minus plus 8H plus. Actually, this balancing can be done by oxidation state calculation, Fe2 plus giving 5 Fe3 plus Mn2 plus 4H2O. This is the actual balanced equation. For oxalic acid, it is 2MnO4 minus plus 16H plus 5 oxalate ion C2O4 2 minus giving 2Mn2 plus 8H2O plus 10CO2. This is the balanced equation. Actually, when the KMnO4 combines with sulfuric acid only in the presence of sulfuric acid, KMnO4 acts as the oxidizing agent because of this equation. K2SO4, the potassium combines with the sulfate ion, and then manganese also is combining with the sulfate ion, and then water is produced. And apart from this, 5 atomic oxygens are generated. Actually, these 5 atomic oxygens, they only oxidize the oxalic acid according to this equation. Actually, oxalic acid is having 2 water molecules of hydration. 2 water molecules of hydration plus atomic oxygen atomic oxygen giving 2CO2 plus 3H2O. So 5 oxygen. Therefore, this entire reaction 5 times takes place. So the overall reaction can be written as 2KMnO4 plus 3H2O, H2SO4 plus 5 oxalic acid giving potassium sulfate plus manganese sulfate plus 18H2O plus 10 CO2. This is the overall reaction. So I suppose you understand the overall reaction of these two titrations, namely redox titration. Now, there is a general question. During the titration of oxalic acid with KMnO4, you might have done this experiment. You pipette out KMnO4 and the KMnO4, sorry, you take the KMnO4 in the burette, pipetted out oxalic acid into a clean conical flask, and one test tube full of dilute sulfuric acid is added, and the content of the flask is heated to bearable warmth. In the burette, KMnO4 is taken. In the conical flask, oxalic acid is taken, and you have added one test tube full of dilute sulfuric acid, and the content is heated for bearable warmth. Bearable warmth means up to 70 degrees centigrade. Why it is heated to 70 degrees centigrade before titration? The reason is, now manganese is a transition metal. So it has the ability to form complex. Actually, the KMnO4 is coming down to oxidize, not to form a coordination complex. It is coming down to form, it is coming down to oxidize the oxalic acid. It should not form the complex because oxalic acid is a ligand, because it has oxygen to donate the lone pair of electrons. So this can act as a ligand, and manganese can act as the central metal atom. It can act as a central metal atom. So they can combine to form a complex. So if a complex is formed, oxidation is not taking place. So I want to make the system undergo oxidation, but not complex formation. Therefore, the complex decomposition temperature is a 70 degrees centigrade. So by heating the content to 70 degrees centigrade, I am decomposing the complex and I'm avoiding the formation of complex. Therefore, KMnO4 will start oxidizing oxalic acid. This may be asked as a question. You should understand why the content is heated. Now, I want to give you a work. I type a question. You try to do this question. How will you prepare try to do this problem? How will you prepare 0.1 normal solution of oxalic acid of volume 250 ml? Try to do this problem and put it in the chat box. Normality is number of gram equivalents present in 1000 ml of the solution. That is equal to weight taken per liter divided by equivalent weight is equal to normality. So how will you prepare weight taken per liter? You don't know. X equivalent weight is 63. Your normality is 0.1. So X is equal to 6.3. So 6.3 gram of oxalic acid, if it is taken in 1000 ml, then you will get a 0.1 normal solution. But you are asked to prepare 250 ml. Therefore, 6.3 divided by 4 will give you the answer 14.223, 5 4s are 20, 330, 30 means 7. Nearly 1.57 gram of oxalic acid taken in 250 ml will give you 0.1 normal solution.